In this video, we're going to take a look at static particles, and we're going to use a basic workflow for distributing objects in a scene. So it's going to be a two-part video. The first part will be looking at static particles that are not animated, and then after that we're going to move on to static particles that can have an animated shape. So that's going to be our overview of static particles. So when you work with particles, you want to use particles to distribute objects in a scene, either it's animated or not. So what we want to do with this scene here is we've got a terrain, and on this terrain we want to distribute some rocks. We've seen how to do this using Reactor by interactively throwing rocks on the ground and having collision detected and all of that. But you can also use particles if you have way more objects to distribute. Always think in terms of when you want to have a lot, like thousands of objects being distributed as scene. Think in terms of particles. If it's just like a dozen or a couple of dozens of objects, you can go with Reactor or use other techniques. But particles is very, very oriented toward the massive amount of objects. So what we're going to do here, we're going to grab the rocks here and we're going to distribute them on the terrain. So to have access to particles, you can go here in Standard Primitive, particle system, and you got a couple of older particle system that are here, but we're going to mainly use particle flow source. I'm not going to add the particle flow source manually here. What I'm going to do is I'm going to go and I'm going to press the 6 key, and when you press the 6 key, it opens a particle view. By default, particle view, I'm just going to maximize this here so we can see a bit better, but by default particle view is empty. So this is our environment here, this window here that is empty. This is where we're going to start creating our particle system. And like we've seen in the class, particle flow is an event-oriented particle system. And when we create static particles, it's pretty much one event that we'll be creating. So how do we start? We're going to go with step 1, which is creating particles. So when you create particles, you've got those two operators here that are birth and birth script. We're not going to take a look at birth script, so we're going to just grab the birth operator here. And when you want to start creating in this environment here, what you do is you take the operator, you click on it, and you drag and you drop into the environment. So now we have this event 01, and we can rename that and say it's going to be rocks on terrain. Here we go. It's identified. So if we've got multiple events in the system, if we've got multiple particles, particle system, we're able to determine what they are. So now we've got a birth event, and we're going to click on it. And as soon as you click on an event, on an operator, you'll see the properties of that operator that are displayed over here. So if I click on the birth operator, I can see that from frame 0 to frame 30, we're going to create 200 particles. So randomly, between 0 and 30, we're going to create 200 particles. That's not what we want to do. What we want to do when we're doing static particles, we want all of those particles to be created at frame 0. We want them to be present throughout all of the animation. So what I want to do is I want to have 2,000 particles into the system. We want to distribute 2,000 rocks on this terrain. So right there, if we tried to do this in Reactor, we would probably end up having a very, very slow rock falling down and try to interact with them. So we're going to use particle flow to distribute those 2,000 rocks in the system. So now that we've got 2,000 particles, right now there's just 2,000 points. We don't see them in the viewport. We don't see them. If we try to render, we would not see anything, because what we've just defined is 2,000 points on which we want to define where they're going to be. We want to define which object will be replacing those points in space. But so far, we just have decided to have 2,000 of those points. So the second operator that we're going to use is the position particles in order to position them on the geometry. So that's the second step of our recipe that we've seen in the class. So here we've got different position operators, but what I want to use is the position object. So I'm going to click on it and drag it and drop it. Like you see that there's a line here. If I drop it here, it's going to replace the display operator. That's not what I want. If I drop it here, it's going to create a new event. And if I drop it like right there in between the two, it's just going to be added to the rocks on terrain event. So now the three operators define what rocks on the terrain will be. So if I grab position object here, now the emitter object is empty. So I'm going to click on add and add this object here. And now the plane 01, which is my terrain here, is now the object where the particles will be emitted. So since I want to be interactively seeing what's going to happen in the viewport, instead of waiting at the end to put the render node, I'm going to put it in right away so that we can see the different steps that we're doing as we're creating the system. So instead of I'm just going to go here and create an empty flow, and if I drop it here, it creates a render node called PF source 01. I could call that and rename this PF source rocks, and I can rename that in order to be able to see what it is. And then what we want to do is we want to feed that event. We want everything that happens in that event to be rendered by this render node. So I'm going to click on it here and drag up to that point here, and now what's going to happen is we've created a link, and you can see here that we can see that in the viewport. Now we're displaying the geometry as sticks. That's why we see those sticks in the viewport. I can define that we're seeing them as circle or as the geometry itself. So that's what I'm going to choose for now. But now we don't have any geometry, so we're just replaced by those little X's there that represent that will be replaced by geometry when we're going to define which type of geometry we have. One of the things to notice is that I'm just going to go here and select the PF source rock, which is this thing here. Select that. And as soon as you select this in the scene, what you have access to is the particle flow source environment. And one of the things that is important here is the quantity multiplier. Right now we are only seeing 50% of what's going to be rendered when we're going to render. So what I want to do here is put 100 so that we can see 100% of the particles that are getting rendered. So it's much more interactive to know what's going to happen when we're going to render. So it's much better to see how we distribute those objects. So now that it's done, we're ready to replace the little X's by real geometry. So in order to do that, I'm going to bring back the particle view here in my environment. I've got a couple of operators here from which I can pick from. And what I want to do is I want to grab the shape instance operator. So again, click, drag, and drop it in my event rocks on terrain, and I'm not replacing any of the operators. I'm just dropping it in, and it's going to be one more operator to define what rocks on terrain will be. Right now shape instance is set to none, so I'm going to grab this button here where it says pick the object in the scene. I'm going to click here and just grab any of the rocks here. It's a group of rocks, so what I've done is I've created multiple objects, multiple rock version. I use the same rocks as we used in the reactor setup, and I just grouped them together, and I'm going to click on that. So now my group is copied every single at every single spot where there was a particle before. So where there was an X, now there's this group of rocks. That's not what I want to get. What I want to do is I want to turn on group members. And here, this option called multi-shape random order, I'm going to turn that on. And now what's going to happen is every X or every particle spot will receive one of the objects in the group. So when you want to create variation, you can create multiple objects, multiple different debris in an explosion, or in my case here, multiple versions of a rock, and group them together and randomly alternate between the shapes. So now we've got various shapes, various rocks positioned everywhere on the terrain. So that's pretty much the shape instance. What we want to do now in the step number 4 of our recipe is we want to define the orientation of our objects here. So right now we have rocks that are all oriented in the same direction. What we want to do is we want to add some randomness to this here. So there's a rotation operator here that I can click and drag into my event again. And now my rotation is set to random 3D, so all the rocks will be in random rotation. What I can do as well is I can select, random horizontal world space. I can orient it exactly in the same direction, and those here will be mostly for dynamic particles as they move through space. But what I'm going to do now is I'm going to create random horizontal, and random horizontal is a really good method to distribute objects if they have an up and down side to them, and you want them to be staying up and down in the correct orientation, you can use random horizontal, and they will be randomized, but always rotating on themselves horizontally. And you can add a little bit of divergence here if you just want to add a little bit of variation to have, for example, if you had trees or plants that you were using the same, they would be oriented up and down in the same way as they were created in the scene. But you would also, by adding a little bit of divergence, you would get some angles from one tree to another. Alright, so now that we've got the orientation defined, what do we want to do? We want to define the scale. It's pretty good right now, but we can still adjust it. So in step 5 of our method, we want to define the scale. So I'm going to go here in the shape instance, because that's where it's done. If we go here, the scale is set to 100%, so I can play with that to reduce it to make it very, very small, or to bring it a little bit bigger, something around maybe 75. And then what I want to do is I want to add some variation on top of that. So by adding some variation, some of them will be much smaller and the others will be bigger, and it adds a little bit more randomness into the terrain, the rocks on the terrain here. So now that we've defined the scale, we want to look at the animation. There's no animation object, so in our recipe we are at the point where we would go and offset some animation. We have no animation, so we're not going to bother about that right now. And what I want to take a look at is a very interesting way of using the vertex paint modifier in order to define where you're going to have more rocks, where areas we're going to have more rocks than other areas. To do this, what I'm going to do, I'm going to go into the position object, and right now they're defined to be distributed randomly on the surface. But what I can do here is say density by material. I'm going to base it on a grayscale value, which means that where the value will be black, we will have no density at all, and where the value will be white, we'll have a high density of rocks. In order to do that, I'm going to use a submaterial, and I'm going to use material ID number 2. So I'll be able to, in the viewport, see the original material on the geometry, but use a second material ID to define where the rocks will be in space. So that's what I'm going to use now. I'm going to just minimize particle view for now, and I'm going to go grab the material that is assigned to the terrain. So I'm going to grab it like so. So that's the material. It's now a standard material, but since I've defined that I want to use material ID number 2, what I need to do is to change the standard material to a multi-subobject material. So I'm going to click here and click OK. And by default, I will say that it keeps the old material as a submaterial, so that material ID number 1 stays the material that we see here in the viewport. I don't need to have all of these materials, so what I'm going to do is I'm going to say I just need 2 material IDs. And now I'm going to use a second material ID to define my grayscale. So if I click here, go into diffuse channel, and I'm going to use vertex color as being the density definition. So now we're using map channel 0, which means that it's going to be vertex color, the vertex color coming from vertex paint that will be used here. So now we've got those 2 material IDs. That's good. It's working so far. I'm going to close that down. And on top of my terrain now, what I'm going to do is I'm going to apply the vertex, oops, not this one, the vertex paint modifier, and I'm going to cover everything in black here. So now that everything is black, I can start to paint certain areas in white. And as I'm going to start painting certain areas in white, you'll see that, whoops, nothing happens. So go back here, position object, density by material, grayscale. That's good. Oh, we just needed a refresh here. So now what we've done is you can see that in black and white I'm painting the vertex color, but it also defines, it's interesting, I'm not getting any refresh here. So grayscale again. So you're getting a refresh when you are refreshing this drop down here. Maybe that's because Camtasia is working, because usually it interactively updates. But anyway, what I'm going to do here, I'm going to go back to the shaded view, and I'm just going to define certain areas here where there's some holes in the geometry, like so, and just refresh that again. And I'm just defining in black and white where I want those rocks to be, or where I want to have more rocks than in other areas, like so, a bit like so. I want to have more here, grayscale, refresh, a bit more here like so, and grayscale, refresh. So we're just defining those areas. That's quite. It's very handy to be able to do this kind of selection, because it allows you to paint where those particles will be. So now I can blur all of this a couple of times. I'm going to refresh this here like so. Maybe refresh again. So it's a bit congested here for the size of the window, but anyway, I'm going to blur a couple of times again and refresh that, and we're going to get a bit more distribution. So that's pretty much how you can use vertex paint. So what you do is you go and position object here, density by material, set up the grayscale, and you can use the material, the sub-material ID. So if you don't want to use the same material that you're going to render and the density material, so you can use multiple material IDs. So that's an overview of particle flow with unanimated particles, and we're going to jump in the second portion where we're going to take a look at static animated particles. And for static animated particles, I'm going to use this example, which is a tree. But we're going to take the regular foliage of 3ds Max a bit further by creating an animation that is a bit more lifelike. So in order to create that trunk here, what I've done is I went into the standard primitives, and I went into I changed that to AEC extended, went to foliage, and I grabbed an American elm. I just created a trunk with no density, and I converted all of this into an editable poly. So let's take a look at what we've done here. So I'm just going to zoom out a little bit so we can see the whole tree, like so. So this is just the branches and the trunk. And if you go into the modifier stack, I've added a couple of animations here, because the goal is to have this shape animated, to have a very natural movement, and we're going to use the particle system to add leaves that are also animated into that whole system. So we're going to get a very natural tree with a very nice animation on the leaves. So you can, this is an example, but you can go further and add it and use the same type of techniques for any type of objects that are animated. But I thought the tree was a good example. So we have an editable poly. I've turned off all of the modifiers so we can see the effect of each of them one by one. So the first one is the bend modifier. So I'm going to turn it on, and you're going to see that what I've done here is just a very basic animation of this going left and right. So if you play it in real time, it's going to be pretty slow. It's very slow movement. And the idea is that the tree like this, because of the resistance of the structure of the trunk, will, if there's wind in it, it's not going to balance. It's not going to move too fast. It's not going to oscillate too fast. It's just going to go very slowly to follow the overall movement of the wind. Now what we've done after that is we applied a poly select operator, and I went in here, and I'm just going to go a bit closer to a branch so we can see. I've pretty much unselected all of the trunk, and I went in the end here of each branch, and I've used soft selection to select the further end of the branch, and it fades off the selection up to the main branch here, which is also unselected. So all the big branches here are unselected, so we pretty much have all of the end of the branches fully selected. So the next modifier here will be applied to only the selected objects there, the selected vertices. So if I go into noise mode here and I turn it on, what's happening now is that this noise is applied only to the end of the branches. So what we've done is we've created a higher frequency noise here. So when we play this, I'm just going to turn off the vertex selection here so we can see a bit better. Whoops, not a good idea. Sorry about that. I'm just going to go back in the stack here and deselect my object. So we hide the vertex selection. So if I play this now, what you're going to notice, it's a bit slower in the viewport, but you're going to have a higher. I'm just going to go closer to the branch here. You're going to have a nice little subtle movement here in the branches that is a bit of a higher frequency in the branches. So essentially, that's what we've done. We've just created this. I'm going to go closer here so we can see a bit better. So if I play this, if I grab it, you see that there's a nice high frequency movement in the branches, so they feel a bit more soft than the main trunk. So the trunk is moving very slowly, and the branches are moving a bit faster. So now what we did is that since we had, like you saw, some performance decrease when we did that, what I've done is I've added a poly select on top of the noise modifier. And what the poly select does, it cancels the selection here because the modifier stack moves up. So we have an editable poly on which we applied the pen, so it applies on the whole editable poly structure. We selected only certain vertices on which we applied the higher frequency noise, and then we put a poly select to cancel the selection that is in the noise here. So now the next modifier is going to apply to the whole system here, and it's a point cache modifier. So we recorded all of the animation in the point cache modifier. So once the point cache is activated, I can turn off all of those other modifiers, and I'm still going to get my full animation, but with much better performances in the viewport, because it doesn't have to calculate all of this. So now you can see that we've got a very nice natural overall movement on the trunk, very slow, but also get very higher movement here in the branches. They feel like there's a bit more of a higher frequency wave into them. So now it's come the time to define, to add leaves in the trunk, and that's why we've added a vertex paint modifier. So if I go at the vertex paint level, I'm going to turn it on, and I'm just going to go in edit mode so we can see what's going on. I'm going to turn off the material here so we can see a bit better what we're doing here. So I'm just going to close that down and show the vertex paint that I've done here. So everything is black except the very end of the branches, and that's pretty much defining how much density I want, how much leaf density I want in every part of the tree. So it's a really good way to define where you want to have leaves. So leaves usually, if you look at a tree, they always appear at the end of the branches. So that's why we created that density map in the vertex paint. So we've created the vertex paint in the vertex color channel, and the material, whoops, not the particle flow, but the material editor. I'm going to bring that back in, material editor here. So what we've done, the material that is assigned to the trunk is material ID 1 is just the color, the texture of the trunk, and material ID number 2, it's just in the diffuse map here, we've just added the vertex color map. So we're using material ID 2 to define I'm using material ID 2 to hold the vertex color information, so when we're going to go in particle flow, we're going to be able to define density by material and use material ID number 2. So that's what we've defined here, vertex paint. I'm going to go back to the shaded view and go back to my material and turn it back on in the viewport so we can see the color of the trunk here. So now that we understand pretty well how the trunk is working, how the animation is working, I'm going to close the vertex paint here. So this is the animation we've got so far. And what we want to do is, now we have an animated shape for the tree, so that's where we want to add our particles. And our particles, what I've done here is I've created 5 leaves here. So I just went in the park and near my house and I took some pictures of leaves, and I tried to get them in random colors so that it feels when they're going to start to be distributed in the tree, they look a bit more random. So if I just take a look at one of those leaves, what I've done is I've created an editable poly on which I've added the same thing, a soft selection with poly select, to have the vertex here where the root of the leaf is supposed to be, for this to be not animated at all, and the noise modifier, which is the next modifier in the stack here, is applied only to the edges of the leaf. So I've done that for every leaves, and I've changed the noise setting for every of the leaf so that we get different variation into the animation. But this is, if we take a look at the leaves here, we have a faster animation pace because they have the higher frequency of movement for the variation. So if there's wind into them, they're going to move very, very fast compared to the trunk that is very resistant to the overall force of the wind. So now that we've got our 5 leaves here, what I've done is I've linked them together. So this one here is linked to this, is linked to this, is linked to this. So if I grab this one here and move it up and down, you'll see that all of the leaves will be following. So that's a chain that is also a really good way to use in particle flow if you want to randomize the use of all of those objects in a particle system. We saw in the previous section how to use the grouping, but you can also use the object and their children to distribute in the particle flow. So now that's pretty much the setup that we have. So I'm going to zoom out to have my whole system visible, and we're going to start using those leaves here to add as particles into the tree that is over there. So I'm going to bring in particle flow, and we're going to follow the same recipe as we did before. So I'm going to try to maximize the window so we can see everything. So I'm going to minimize this here, bring back that like so, and try to work this way. Okay, so step number 1, we need to create particles. So we need to create particles. Since it's static particles, I'm going to use a birth event here. I'm going to bring that in. I'm going to create, to start with, I'm just going to create 50 particles to have 50 leaves. and I'm going to emit at 0, and from start to beginning, all the particles will be emitted at 0, like we did before. I'm going to make sure that we have a render node at the end, so I'm going to put an empty flow here and connect it to it, like so. We could have waited until the end to connect it to the render node, but I want to see what's going to happen as I move to the different operators. So we're just going to put it right away to see it in the viewport. Now that I've got my particle flow source, I'm just going to go in, I'm just going to use the H key for select by name, particle flow source. I'm going to make sure that the viewport here shows me 100% of the particles. And since those particles here are double-sided, I want to see their backface. By default, all of the objects in Max have their backface culling property set to on. So in an event like this, you have to go into properties and also set the backface culling to off so that we can see the back of the particle. So there's just a quick, if you want to adjust any properties of an event, you just go here and right-click in the top bar, go in properties, and you can adjust all of this. So if you want to have motion blur on an event, you can do this way, but to turn off backface cull, I'm just going to turn it off right here. So now what we've got is a display of the ticks, and what I'm going to do is I'm going to display the geometry. So when we're going to have geometry, we'll be able to see it in the viewport. So step number two, what we need to do is to position the particles on an object. So we have the object here. So I'm going to grab the position object operator, grab it in. I want to position all of this on the trunk here, so I'm going to add that object as the emitter. And as you can see now, we've got the object emitting particles. The thing is that remember that we used the vertex paint modifier to define where we wanted to have particles. Right now we've got particles on the trunk, on all of the branch. You see some particles over there. I don't want that to happen. I want the leaves to be only at the end. So I'm going to go into position object. We're going to go down here. We're going to say density by material. We use the material ID number 2, so we're going to turn on use sub-object material, and I'm going to use material ID number 2. So as soon as I do that, you see that I don't have any more particles on the trunk here. They're all at the end of the branches there. So that's exactly what we wanted. That's perfect. We're ready to continue with that. So now that we're done with the position of the particles, what we'll do here, we'll go into step number 3, which is instancing objects. And if I do that here, I'm just going to go and grab the shape instance. So like so. My shape instance here, what I want to do is I want to make sure that I'm using the object and children, so it's going to alternate between the object and its children, and I want to do a multi-shape random order so that I get variation into my particle system. So here we go, shape instance. I'm going to grab let me just go here and grab the first leaves. That's the first one here. That's the parent of everything. So as soon as I'm going to click on it, it's going to add the particles, and it's going to randomize all of the particles in the tree here. And they're going to be oriented in exactly the same way, because step number 4 is to define their orientation. So I'm going to go here and grab a rotation operator and drop it in the event. By default, rotation is set to random 3D. It could be a good solution. It's going to add a lot of randomness into the tree here, but this is not how real trees and how real leaves are behaving in real life. So actually, because of the leaf itself is a bit heavier on its end than on its root, it's going to tend to fall down. And if you look around in real life, that's what you're going to start seeing. So what I'm going to do is I'm going to say define the leaves orientation in world space. And now they're all defined to be looking in the same direction in world space, which is pretty boring right now. So what I want to do is I want to orient them so they look down. So I'm going to go here in X, and I think it's around -90 in X, -90. And in Z here, so now they're all looking in the wrong direction. So I'm going to go here in 180 degrees. So now they're all pointing down, but they are all pointing down in one direction, so that's not very interesting. So what we're going to do here, we're going to restrict, we're going to add some divergence, 180 degrees, but we're going to restrict that divergence in the Z-axis only, and we're going to give it 180 degrees. So what's going to happen now is that all the leaves will be pointing down, but there's going to be some, actually, whoops, going to put 0 in X here. All of the leaves will be pointing down, but they're all going to be pointing in different directions. So I can also give a little bit of divergence here, maybe 0.1 or 0.2, to have them also have some divergence in the X-axis. So you just define how strong you want that divergence to be in all of the axes, but we want them to be rotating in all directions. So now they are pointing down, but they're also pointing down in various directions. So you're going to see leaves from all direction in the tree. So that's pretty good. Now that we're defined with the orientation and the randomness of the real orientation, we need to adjust the scale. So if we go into the shape instance here, we have currently set to 100%, so the leaves are very big. So I'm going to reduce their size here, and pretty much like so, maybe 36%, 35% will be good. That's what I did in the previous in my previous tests. So that's pretty good, around like so. So the leaves are pretty much to scale to that tree. And I want to have a variation also to get some trees bigger than the other, so maybe like 40% or something like that. And again, it's a question of eye. You can just go closer and make more accurate settings if you want to. So now that we're defined with the scaling, it's time to deal with animation, which is a new concept compared to the previous particle system that we have done. So animation, we need to define two things. We need to define that the shape, the position object where we're emitting particles from, is going to be moving during the animation. So I'm going to go here and position object, and I'm going to tell the computer whatever the object is doing, all the particles should be locked on the emitter. So what's going to happen if this object is moving, the particles will be following with it. But the thing is that the lock on the emitter, if you only use that setting, is going to be only affecting the position and rotation of the object in itself. So if you want to animate the internal shape using all of those modifiers, the shape is changing for that object, I have to make sure that I turn on animate shape as well. So now what's going to happen is that the particles will be, it's going to slow down the system a little bit. I'm going to turn off real time. That's good. So now if I play the animation, you see that the particles, it's probably not going to be that obvious, but as the shape of the structure of the tree is moving, you see that the particles are following the shape. So they're locked on the emitter, but they're changing, they're moving with the shape of the tree. So now that we've got this going, that's pretty cool. Now we have to think about the animation of the particles themselves, which are the leaves. So we've created an animation, and we want to take advantage of that. So I'm going to go into the shape instance here, and we're going to tell the computer that the leaves or the particles are also animated. So I'm going to turn on animated shape. And if we want to randomize the playing of the animation for each particle, so we can say animation offset keying, turn on random offset by absolute time, and then you can just say whatever value you want, 37 or any randomness, and now all of the animation for the leaves will be playing separately. So that's what we got now. If I just play this, you'll see that it's going to slow down the system quite a bit, because we've got a lot of calculation and vertex information that's happening right now. So that's where the make preview animation is interesting in a case like this, because if you want to have a feel of the movement of the overall scene, you need to make a preview of your animation. You're not going to be able to see it in real time in the viewport. So now that we're pretty much done with the random of the animation, we're ready to output it to a render node. So we already have done that, but now that we've got our system working pretty well, I only have 50 particles. So if I want to provide a better system or a better, more furnished tree, I'm just going to increase this, and in my testings I've went to about 2,000 in terms of amount that looks pretty good. So now I've got 2,000 particles. I don't need my particle view anymore, so I'm just going to close that down, and that's pretty much my tree. And I'm just going to orbit around here so we can see a bit better. So that's the tree if you look at it from all directions. So now what's going to happen with this tree is that we've got the animation on the trunk, the animation on the branches, and also each leaf is being animated by itself. Of course, if I start to play this, it's going to be very, very, very slow. So I'm going to rewind this, and I'm going to show you the animation that I've done with the preview. So I'm going to go here in animation and view preview. Oh, I've got no preview file, so I'm just going to go here in my temp directory and just load up the last animation that I've done. Here we go. I'm going to bring it to the window, like so, and stop it. And this animation is provided in the folder as well. So this is the animation that we get. So we got really slow movement on the trunk here. Every single branch is moving a bit faster, so you get really nice soft movement in the branches, and each of the leaves is animated with a very fast high frequency pitch here. So that's what we get as a particle system. So what we've done here, we've created a static particle system in terms of like all of the particles here, all of the leaves do not change state during my whole animation, but the shape of the particle emitter and the shape of the particles are animated. So we had to turn on the animation settings in there and also randomize the animation playback. So that's it for static particles. In the next section of the class, we're going to take a look at dynamic particles. And dynamic particles have one then more events, so particles change states when you go from one event to the other.